Hello students, this is Mr. Allen, your geometry teacher, and today we are going to move on to chapter 4, and we're going to look at section 4.1, which is on congruent figures. Our objective today is to recognize congruent figures and their corresponding parts. So congruent figures or congruent polygons have congruent corresponding parts. That is, their matching sides and angles are congruent. So for example, if we look at our two trapezoids right here, and below those two trapezoids, you'll see a congruent statement. This is the congruent statement right here. The congruent statement tells us all the matching parts. So for example, you see this red angle A, that angle has to match up with this angle E. And if you look at the two shapes, we can see that those are the two angles that, in fact, those are the only two angles in those two trapezoids that appear to be obtuse. So we know that angle A and E are congruent. Similarly, we know that angles B and F are congruent. It also tells us which sides are congruent. So I'm going to go ahead and erase that ink. So for example, this side here, we can see how there's CD in this congruent statement, and that matches up with the third and the fourth letter in the other statement, so that's GH. So we know that segment CD has to be congruent with segment GH. Now in this case, we have 4 corresponding pairs of angles and 4 corresponding sides. So that means we have a total of 8 parts that are corresponding and congruent. The order in which you write these letters in this congruent statement is very important, and it cannot be contradictory. So let's look at an example. It says if HIJK, that's this quadrilateral over here, is congruent to this quadrilateral here, what are the corresponding parts? So this is similar to what we just looked at. So there's a quadrilateral, so we're going to have 8 pairs of things. You may want to stop the video now and list them. And I'm going to go ahead and start doing that right now. So first, let's start with the angles. So all the information, like I said, is given in the problem or in the congruent statement. So for example, the first letter here is H, that's this angle here. That means since H is first here, that means L has to match up with that. In other words, angle H has to be congruent to angle L. Similarly, angle I, which is the second letter, guess what that has to go with? Well, angle I is the second letter in this statement, so that means it has to be congruent to angle M. What about angle J? Well, angle J is the third letter, so that means it has to be angle N. And then let's see if I can squeeze this last one in here. So angle K is going to be congruent to angle, well, again, K is the fourth letter, so look at the fourth letter here. So that's angle O. So those are all of the corresponding angles, and they are all congruent since these two shapes are congruent. Now I'm not going to list all, well, maybe I should. I'll list all the sides as well. I'm going to go a little bit faster now. So here's all the corresponding sides which are congruent. So again, I am simply going to use what's given to me in the definition up here, this congruent statement. So HI, that's this side here, side HI. So segment HI, well, that has to be congruent with the first 2 letters of the second one. So that's going to be segment LM. Segment IJ, that's the second and the third of the first. So that's going to be congruent to segment MN. Segment JK is going to be congruent to segment NO. And finally, segment, and this is where we're going to be careful. Now I'm going to use the last letter and the first letter. Segment KH is going to be congruent to segment OL. So those are all of the corresponding congruent parts. All right, example 2. This one's a multiple choice, and I'm not sure if you're familiar with this, but this is the SR-71 Blackhawk. It is a very fast plane, and it says the wings of this plane form congruent triangles. So what I've done here is you can see that we've pulled out those two triangles in the left and the right wing. And it's asking us, what is the measure of angle D? So let's first write a congruent statement for these two triangles. So it kind of looks like to me that angle, it should be like, let's just go, we'll call that first triangle. It looks like triangle ABC is congruent. Now, this was the outside, right? So we got to be consistent here. This was the outside over here. So here's the outside on the other side. So that means this is going to be congruent to triangle DEF. Now you can't just list that in any order. Since I went from outside to the top to the back, I need to go from the outside to the top to the back, since there's a symmetry with respect to this particular airplane. The left side looks like the right side. Now we're trying to find the measure of this angle right here. Now we know that angle B and angle E are matched up and they both measure 30. That's given. What would be the measure of angle F? What's the measure of angle F? Well, since angle F has to be congruent to angle C is 75 as given in the diagram, so angle F has to also be 75 degrees. So that tells us that in our triangle, and I'm going to erase this now on this side, in this triangle now we've just figured out that this angle F is also 75 degrees. And now we can use our triangle angle sum theorem, which tells us that all of the angles have to add up to 180. So I'm going to say the measure of angle E plus the measure of angle F plus the measure of angle D equals 180. And I'm going to start substituting in what I know. Well, I know that angle E is 30, so that's 30 plus the measure of angle F, that's 75, we just figured that out, plus the measure of angle D equals 180. So now I have, well, just one unknown, which is D. So I can add these two guys together, which I think that's going to give us 101. I'm going to have to kind of go up here. That's going to give us 105 plus the measure of angle D equals 180. And then, of course, I'm now going to just subtract both sides, 105, 105, and that looks like that the measure of angle D is 75 degrees. So it turns out, looks like that those angle F and angle D look like they are congruent. All right, so here's our final comment today, which is the third angle theorem. And here's what the theorem says. If two angles of one triangle are congruent to two angles of another triangle, then their third angles are congruent. We kind of saw that on this last one. We saw that if this angle was 30 and 75, and this angle was 30 and 75, well, it turns out that angle A and angle D are going to be congruent as well. So here's, remember, we're talking about a conditional statement, if-then statement. If in this case angle A is congruent to angle D in this triangle, and angle B is congruent to angle E in this triangle, and that triangle, therefore angle C and D also have to, or I'm sorry, angle C and F have to be congruent. So let's see if we can get an answer here for this. It says, are these two triangles congruent? Okay, so in order for those two triangles to be congruent, in order for this to be true, all of their corresponding parts, all of their corresponding parts have to be congruent. Okay, so let's see here. It looks like that angle A is congruent to angle E, so that's good. We can see that they're both marked with a single mark. Looks like that angle B is congruent to angle D, all right? Okay, so now I can use that theorem that we just said, and this last theorem told us that if two of the three angles are congruent on the corresponding angles, or triangles, then their third angle has to be congruent. So that also then tells us that angle BCA has to be congruent to angle DCE. In other words, I'm talking about this angle here and this angle here. And by the way, that was by theorem, and let me make sure I say it correctly, theorem 4.1. Theorem 4.1 tells us that why that one's true. Okay, so we got all the corresponding angles congruent, so that's good. Now let's start looking at their corresponding sides and making sure that they're all congruent, and if they are, then we're good to go. So let's see here. Well, is side AB and ED congruent? They are, so I'm going to write segment AB is congruent to segment ED. Well, let's see here. CD is 4 and BC are 4, so those have to be congruent. So BC is congruent to segment CD. And last but not least, we've got segment AC is congruent to CE. So those corresponding sides are congruent. So guys, we have all three corresponding angles and all three corresponding sides are congruent. So now I can finally reach my conclusion. Therefore, triangle ABC has to be congruent with triangle. Now here's where we're going to be careful. The order of the letters is very important. Since I went from A to B to C, I have to go in the same order. So angle A corresponding with angle E. So that if that A is first here, E has to be first here. If B pairs up with D, so that's got to be D. And then, so it's going to be C. And there's your congruent statement. Those two triangles are congruent, and they are congruent by the definition. This is by the definition of congruent figures or shapes. Okay. And the last thing we're going to do today is we're going to look at a proof. So here's what the proof is. It says, given that segment LM is congruent to segment LO. So we've got this segment here congruent to this okay, good, I can see that. And then it says segment MN, that's this guy, is congruent to segment ON, that's that guy. Okay, that's good. And we also know that angle M is congruent to angle O, and angle MLN is congruent to angle OLN. And the question is for us to prove that angle LMN is congruent to angle or triangle LON. So again, in order to prove that these two triangles are congruent, we have to prove 6 things. The good news is we've already got 4 of them. So we just got to get 2 more. So here's, if you want to think about it this way, we have, here's one side congruent to one side, here's another side congruent to another side, here's a third side congruent, or a third angle, or an angle congruent to an angle, and then here's number 4, here's an angle congruent to an angle. So we need to do 2 more things. So we need to somehow show that this side here is congruent to this side in both the triangles, and we also need to prove that maybe this angle here is congruent to this angle here. So let's see if we can do all of those things. All right, I'm going to erase all of this. Okay, so step 1 says that LM is congruent to L. Oh, okay, what's usually step 1 in any proof? Well, it's given. So we know that those segments are congruent. Now, step 2. Why is segment LN congruent to segment LN? Why is, oh yeah, that's that reflexive property. So now I'm going back and I'm hitting some of those properties that we talked about back in chapter 3. That's the reflexive property. The reflexive property says that something's equal to itself. Now, step 3, why is angle M congruent to angle O and angle LM? Oh yeah, that was also given. That's given right there, so that's given. Okay, so that's interesting. This is a proof where there's actually 2 different steps for given. Now, step 4, why is angle LNL congruent to angle ONL? Well, it turns out that it's this theorem that we talked about just today, the third angle theorem, theorem 4.1, which says that if 2 angles, 2 corresponding angles and 2 triangles are congruent, then their third angles have to be congruent. So we know that 2 of the 3 angles in these 2 triangles are congruent. Therefore, the third angle has to be congruent. So I'm just going to write this I'm going to call it the third angle theorem because that's what it is. Or you can call it theorem 4.1. Well, guess what, guys? I said there was two more things we needed to prove. We needed to prove another side was congruent to another side, and we needed to prove another angle was congruent to another angle. We have all 6 things that we need. Therefore, we can prove that these two triangles are congruent, and that's by the definition of congruent figures, or in this case, I'm going to go ahead and just call it triangle, okay? Congruent triangles are going to have 6 corresponding parts that are congruent, 3 corresponding pairs of sides and 3 corresponding pairs of angles. That is that for today's video.